So this is the Sketching Polynomials video part 2. We just above sketched a graph. It was even, and we found the roots, and we found all the curves, and we sketched it. Now I'm going to give you 2 more examples for some different shapes that you might get on the graphs. So here is the function. F of x equals x minus 2 squared times x plus 2 squared. So you'll notice that this is, first of all, 2 binomials that are squared. The first thing that we have to do is find the degree, and in this case we count the x's. So we have 1x and 2 x's, but remember that they are both squared, so actually we have 4 x's altogether, so that means it's a degree of 4, which is even. Alright, next we need to find the y-intercepts. For the y-intercept, we'll plug in 0 for x and then solve. So 0 minus 2 squared, 0 plus 2 squared, we get negative 2 squared is 4. 2 squared is 4, so that equals 16. So our y-intercept is 16. Next we need the zeros. So we would take each of those binomials and set them equal to 0. So that means our zeros are going to be 2 and negative 2, or same thing as our roots. Now, this is where it's pretty important to recognize that those roots are what are called double roots. And they're both double roots because they come from binomials that are squared. And if I expanded this whole thing, so if I wrote it as x minus 2, x minus 2, x plus 2, x plus 2, when I solved, I would get negative 2 twice, and I would get positive 2 twice. So that's why they're called double roots. Double roots are important because it changes the shape of the graph. Alright, so now that we have our zeros, we're going to do our number line and set up our sign graph. So here's our number line. We've got negative 2 and 2, dotted area, dotted area. Okay, so let's look at the values here, the values that are less than negative 2. So we pick a value like negative 3. Alright, if you plug in negative 3 to x minus 2 squared and x plus 2 squared. If I plug in negative 3, I get a negative for this term, but then I square it so it becomes positive. I would get a negative for this term, but then I square it so it becomes positive, so the whole thing is positive. So the whole thing for that area is positive. That means our graph is above the x-axis for any number less than negative 2. Alright, now let's look at our area between negative 2 and 2. So let's pick 0, because 0 is easy. So if we pick 0, I would get a negative 2, but negative 2 squared is positive. I would get positive 2, and positive 2 squared is positive, so the final thing is positive. So that's also above the x-axis. And then finally, looking at our last section here, we're going to choose a number like positive 3. And if I choose positive 3, my first term is going to be positive, my second term is going to be positive, so the whole thing is positive. Alright, so what this tells us is that our graph never crosses the x-axis. But we know that it has to touch the x-axis at negative 2 and 2. So when we sketch this, one of the things that we're going to find out is the shape of a double root. So we've got negative 1, negative 2, 1, 2. We know that we're going to touch at negative 2, We know we're going to touch at positive 2, and we also know that it goes through 16. And notice this is not to scale, but I'm going to label it as 16. All right, so what happens with a double root is that your curve basically comes down to the axis, touches it, and then curves back up, basically forming a parabola type shape. So we're starting above the x-axis. We're going to curve down to the 2 and touch the axis. We then curve up to the 16. We curve back down to the positive 2 and then back up. Okay? Make sure those are curves, put arrows on the ends of your lines, and that is your sketch. So the point here is that a double root touches the axis and then turns back around. You can also have double roots that are both under. So if this were a double root, it could come up to the axis and touch it and then go back down. That would be fine. Okay? So far you know about single roots and double roots. All right, let's go with the last example. This one is f of x equals negative x plus 1 2x minus 5 cubed. All right, so what do you think the 2x minus 5 cubed is? Well, it's called a triple root. All right, so first let's find our degree. With this problem, the degree is going to be, we've got 1x here, and then this is actually 3 x's because it's cubed, so 1 and 3 is 4, so our degree is 4, so this is even. So that means the arrows are going to point in the same direction by the time we're done. All right, let's find our y-intercept. We're going to plug in 0 for x, so we have negative 0 plus 1 times 2 times 0 minus 5 cubed, so this ends up being negative 1 times negative 5 cubed. So we've got negative 1 times negative 125, which is positive 125. So our y-intercept is positive 125. All right, now we're going to find our roots or our zeros, and in this case we've got a root at negative 1 and another root at 5 halves, and this one is a triple root. And it's a triple root because that binomial is cubed. So since this comes from here and that whole thing is cubed, that is a triple root. Okay? So again, a single root just crosses the x-axis. A double root touches the x-axis and then goes back the way that it came. A triple root is going to cross the x-axis again, but it does it in sort of a weird way. So we'll demonstrate that in a minute. All right, so now we need our number line. On our number line, we're going to have negative 1 and then 5 halves, which is the same as 2.5. So pick a number smaller than negative 1, like negative 2. And our original function is negative x plus 1 2x minus 5 cubed. So no matter what number we choose, we're going to have a first part that's always negative because of this negative that's out front. All right, so if we choose negative 2, this first term is negative, this next term is negative, and this last term, if we choose negative 2, that gives us negative 4, negative 5, which is negative 9, cube that, which is negative. So this whole thing ends up being negative. All right, so that means we start below the x-axis in this area. All right, in between negative 1 and 2.5 is 0. That's easy, so let's choose 0. Well, it starts out negative because of that negative sign. This term would be positive, and the next term is going to be negative. And negative times negative is positive times positive is positive. So this ends up being positive in the area between -1 and 2.5. All right? After we get to 2.5, so what's bigger than 2.5? How about 3? It starts negative. The next term is positive, and 3 times 2 is 6, so that would be positive. But this whole thing then ends up being negative, because positive times positive times positive is negative. So this area is negative. Okay, so we're going to do our sketch. Our y-intercept is positive 125, so that's going to be up here somewhere. We go through -1, and then we go through 1, 2, 3. We go through 2.5. All right? Okay, looking at our sine graph, we're going to start in negative territory. So that's down here. We're going to go through -1, because that was just a single root. We're going to head up to 125, and who knows what's happening up here. There could be a whole bunch of stuff. But for us, we'll just do this. All right, now as we turn back and we come down to the 5/2, that's a triple root. So a triple root means that you're going to change inflection. And what that means is that the curve is kind of going to change shape. So it comes down towards the dot like it's holding water, goes through the dot and switches, so now that it's like pouring water. And then we put our arrows in the end. You can think about, I mean, it makes a lot of sense because remember an x cubed graph has that shape where it looks like this S kind of shape. So anytime you have a triple root, you have that shape surrounding the point. Okay? And you need to make sure that this area, this place that you call the triple root, you need to make sure that that doesn't look like a straight line. It needs to have a curve that changes shape. So it might be like that, or it might be like this. But you need to make sure it looks like that. Don't make it look like a straight line, or it'll be wrong. Okay, so now you know how to graph. You know how to do single roots, they cross the axis. You know how to do double roots, they touch the axis and then go back in the same direction. And you know how to do triple roots. They cross the axis, but they change inflection. So they go from, they look like a little S shape. All right? I hope this was helpful, and you can practice more problems by going to Final Sight. Thanks!